Hello, this is Chemistry 1306 homework help. We're nearing the end of the semester, so we will be working on nuclear chemistry. This segment will be showing nuclear binding energy. From here, we will go to calculating the nuclear binding energy with Bismuth. So right here, I have the denoted symbol for the atomic weight and also the protons. This right here is the atomic mass unit that was provided by the question. So I will zoom in just so you can see a little better. This over here is a nuclear power plant, not a tree. So let's begin. We will start with how many protons we have. We've already have it written down right here, so I'm just going to go ahead and write it down there. Subtracting the protons from the molecular weight, we gather the neutrons. From here, by multiplying these two numbers by the constant at which the protons weigh and the neutrons weigh, we collect these answers over here. So this is very accurate. It's 83.6498 AMU, and then the neutron is 127.0918 AMU. With these numbers, we actually will add them together to collect a new AMU, and with that number, we will subtract it. We'll subtract it by the number that we were given at the beginning of the equation, right there. So coming back down here, we subtracted it and we got this number. This is the difference between the mass of the element. Now, using this formula right here, E equals mc squared, the formula that we saw when we were all young in cartoons as a joke, is actually being played in science today. We'll actually use this equation. We'll place our energy, our change in energy, and the constant for the speed of light, 3.00 times 10 to the 8th meters per second squared. We come down here, this is the answer we gathered, and we do the change in energy. So we place our answer and multiply it to get the moles. We use Avogadro's number, remember, the 6.022 times 10 to the 23rd. And we also do the conversion so we can actually work with a little bit easier numbers. So down here, I have the answer we gathered from this equation here. Now notice it's to the -10. That's way better than having such a large number. So we go down here, and this is actually the units to have energy. So we have -2.63 times 10 to the -10 joules, and we divide that by 209 nucleons. And why do we divide that by 209 nucleons? Because if you come back up here, our original mass given to us at the beginning of the class, or the beginning of the problem, is 209. So we're finding individually how much energy per nucleon, how much binding energy per nucleon. So from here we divide that and we get 1.26 times 10 to the -12. That's a -12 joules per nucleon.